Assalamualaikum and hello. Our group will be presenting about consumer electronics. First of all, let me introduce the member of this group. I am NAZZRA AZERA, and we also have NORNAFIESHYA Erika and RUTH in this group. I'm going to talk about the introduction of consumer electronics. Consumer electronics refers to electronic devices designed for everyday use, primarily for entertainment, communication, and productivity. Usually found in homes, these gadgets are designed for individual usage. Products that are included under the category of consumer electronics include a wide range of items such as computers, smartphones, cameras, television, and various home appliances. Consumer electronics have significantly evolved over time, influencing how people interact, pass the time, and perform daily tasks while still keeping up with technological innovation and societal demands. Significance of consumer electronics. Firstly, it has made communication more accessible and enabled instant communication and connection with people globally. Next, provide a wide range of entertainment options and offer access to a vast array of content, thereby enriching cultural experience. Next, contribute to the concept of smart homes, offering convenience such as thermostat, security camera, and voice-activated assistant that enhance comfort and efficiency. Next, drives economic growth and creating more job opportunities due to the constant innovation and consumer demand for new technology. Lastly, the industry is putting more of an emphasis on developing more environmentally friendly goods, cutting down on electronic waste, and embracing green production techniques in order to reduce its environmental impact.
And now, I will explain about the relevant electricity and magnetism concepts in consumer electronics. The first one is electric currents. Consumer electronics rely on the flow of electric current, which is the movement of electric charge. Most devices operate using direct current or alternating current. Batteries typically supply DC, while AC is what you get from wall outlets. Resistance. Resistance is the opposition of the flow of electric current. Components like resistors are used to control the amount of current flowing in a circuit. Inductors. Inductors store energy in a magnetic field while current flows through them. They are used in devices like transformers to change voltage levels in a circuit. Lastly, many consumer electrics such as radio, cell phones, and Wi-Fi devices use electromagnetic waves to transmit information wirelessly. These waves are a combination of electric and magnetic fields oscillating at certain frequencies.
Now we are going into a detailed explorations of electricity and magnetism in consumer electronics. In power supply, consumer electronics often require direct current to operate, while power from the grid is alternating current. Devices like rectifiers and converters convert AC to DC to power electronic devices. And many portable consumer electronics rely on batteries that provide DC power. Rechargeable lithium-ion batteries are prevalent due to their high energy density and voltage stability. While in wireless communications, devices like smartphones, Wi-Fi routers, and Bluetooth speaker utilize electromagnetic waves to transmit data wirelessly. The principle of electricity and magnetism underlie the generation, transmissions, and receptions of these signals. And in electric motors, various consumer electronics contain electric motors that convert electrical energy into mechanical energy. These motors rely on magnetic fields generated by current flow to produce motion.
Here are some examples of real-world implementations of electricity and magnetism concept. Electric motors are integral components of washing machines. They operate based on the principles of electromagnetism, converting electrical energy into mechanical energy to rotate the drum using washing machine and spinning cycles. Here's how electricity and magnetism work together in this context. First of all, the motor contains coils of wires wrapped around the metal core. When an electric current flows through these coils, it generates a magnetic field around them due to the principles of electromagnetism. Secondly, the generated magnetic field interacts with a stationary magnetic field created by permanent magnets or another set of coils, causing the motor's rotor, typically attached to the washing machine drum, to rotate. This interaction what enables the motor to produce mechanical motion. As the electric current continues to flow through the coils, it sustains the magnetic fields, which in turn keeps the rotor spinning. This process converts electrical energy from the power supply into mechanical energy, allowing the drum to agitate and rotate. By regulating the amount of direction of the current flowing through these motor's coils, the speed and direction of motor's rotation can be controlled. This control mechanism is achieved through electronic components that manage the flow of electricity to the motor. The second example is electric doorbell. When you press the doorbell button, it completes an electrical circuit. The completion of the circuit allows electric current to flow from power source such as battery or home wiring through the doorbell system. The current flows through a coil of wire in a doorbell, creating magnetic fields around the coil. These magnetic fields attract a metal piece towards the coil, causing it to move. As the armature moves, it either strikes a bell, producing a ringing sound, or activates a buzzer, or creating audible alert. When you release the doorbell button, the circuit is broken, interrupting the flow of current. This stops the magnetic field, allowing the armature to return to its resting position.
Potential benefits and challenge of electricity and magnetism in consumer electronics. There are benefits including electricity is the primary source of energy that powers consumer electronics. It allows these devices to function whether they are plugged into an outlet or operated using batteries. Next, electromagnetic principles are employed in transformers and power conversion circuits, allowing for efficient conversions of electrical energy from one voltage level to another. This efficiency ensures that the energy is optimally utilized and reduces power wastage. Lastly, magnetism and electricity are employed in various sensors and feedback systems in consumer electronics. These sensors provide accurate measurement, feedback, and control mechanisms in devices like thermostat, cameras, and touchscreens, enhancing user experience and device performance. There are challenges of electricity and magnetism in consumer electronics. Firstly, electronics generate electromagnetic fields, leading to potential interference issues. EMI can disrupt the performance of nearby devices, causing malfunctions or signal degradation in sensitive equipment like medical device or communication system. Next, consumer electronics aim for energy efficiency. However, optimizing power consumptions without compressing performance remains a challenge, especially in high-power devices like gaming console or high-performance computers. Lastly, electrical currents passing through components generate heat. In densely packed devices, managing heat dissipation becomes a challenge. Overheating can affect performance, reduce component lifespan, and even pose safety hazards.
What are the future development and innovations? Firstly, enhanced energy storage and efficiency. Research into advanced battery technologies such as solid-state batteries or new materials for capacitors aims to improve energy storage density and efficiency. This could lead to longer-lasting batteries and faster charging times for consumer devices. Secondly, wireless power transfer. Improvements in wireless charging technologies could lead to greater convenience for charging devices without physical connectors. Advancement in resonant and long-range wireless power transfer could eliminate the need for cords and plugs altogether. Thirdly, sustainable and eco-friendly electronics. Focus on environmentally friendly materials, recycling methods, and reduce energy consumption during the manufacturing process can lead to more sustainable electronics, reducing the environmental impact of consumer devices. Lastly, energy harvesting. Research into energy harvesting techniques such as utilizing kinetic energy from movement or ambient energy from the environment may enable the creation of self-powered devices that require minimal or no external power sources.
In essence, electricity and magnetism form a backbone of consumer electronics, powering our devices and enabling their function. They allow for compact designs, efficient energy use, and wireless connection, and much more. Yet, challenges like signal interference, heat, energy efficiency persist. The future holds exciting possibilities such as better batteries, wireless charging, smaller devices, and eco-friendly practices. By tackling these challenges and exploring new frontiers, the future of consumer electronics promises are even smarter, more efficient, and eco-conscious devices that are better serve our needs. Collaboration among innovators will be key in making these advancements a reality. That's all from us.